Hey there, my name is Bailey Baird.
Hello, my name is Saul Garibay. I'm a part of Teammate for the service robots for wolf care at the Phoenix Zoo.
Hello everyone, my name is Taiwo Michael and I worked on the Etabot and Work Collaboration section of our project.
Why we created these robots, well, especially for injuries and to help prevent any repetitive tasks. We know that strength, intelligence, and aggressive feeding is very common with these animals. We want to keep our any people away from animals as much as we can. We want to be able to keep uh, people from getting hurt. We want to keep people from having to do continuous tasks that could cause them to get injured or anything like exposed to bacteria like E. coli or Salmonella that can be both harmful to staff and for animals. The tools we're using are just for the feeding, cleaning, and supervision. It helps out throughout the task, throughout the day, and keeps them monitoring throughout the night, so we don't have to have someone always there 24/7. This is going to have different kind of hills and valleys that it has to be able to maneuver. It has a moisture sensor to detect wet or contaminated areas that need to be cleaned up. It has a camera motor or camera for visual waste that it can identify. It has a sensors on the front and back side for collision avoidance to not hurt any animals and run into any other machines. Uh, Also added rolling brushes so that as it needs to clean up, it can use the rolling brushes if it's anything that's not able to use the suction. It also has a suction motor so that there's anything that's a liquid or just able to collect through the suction it can. Uh, there's an Arduino microcontroller that controls all the sensors and the actuators. It's a remote controlled wireless, allows Zookeeper to override any precise cleaning that needs to be done. That's really it. Here's the designs and then the wiring for this design. Here's the Den Clean, the algorithm and the flowchart. The Arduino drive uses four DC motors for territory navigation. The moisture sensor detects contaminated areas. The IR sensor, or proximity for the camera, identifies waste visually if it's not anything that's liquid or something that can be detected from the moisture. The sensors motors prevent any collision with any objects, whether that be the
The Etabot, the goal is to make feeding safe and automatic. The robot uses ultrasonic sensors to avoid obstacles and animals while moving. I added a servo motor that opens and releases the food when the operator activates it. The Etabot is controlled with an IR remote and follows a simple program route to reach the feeding area. The Etabot also contains temperature sensors to keep the food warm and two DC motors for movement. And this is the flow chart.
Here, as you can see, these are some of the parts in the circuit. So the DC motors are for movement. Here, obviously, we have the two temperature sensors, which you can see on the body here. The casing is its own thing. And then the antennas, this would be the IR sensor here for the remote to be able to control it. And then the legs, you can't see a part of the circuit, but they are retractable. And that is what will allow the camera to be able to roll around the floor. And in the circuit, we do have like a photovoltaic sensor, and that's just simply to simulate the camera. So this is the flow chart. Essentially, this is basic troubleshooting for the robot should anything fail. And for the majority of the system, it would just need to be rebooted. So now, as you can see, this is a decision matrix for our robots. And as you can see, it's basically just giving you the basic rundown of our decision-making process. Safety was the main concern because there are a lot of injuries in zoos that have to do primarily with feeding and just other things that also went into our decision process was that not only were they expensive, but they also would not withstand the environments, like the treatment from the animals.
I'll now demonstrate how the three robots move together. First, the operator turns on the patrol rover and it begins moving around the enclosure. Using its camera, motion sensor, and temperature sensor, and continuously sends live video and alerts the operator if anything unusual is detected. Next, the Ether is turned on and moves into the enclosure. It uses the ultrasonic distance sensor to check for animals and obstacles. If it detects anything, it turns right and continues moving till it gets to its feeding point. And then the servo motor is turned on to release the food. After feeding, the Denki robot is turned on and it uses the moisture sensor and waste sensor to detect waste. After it is detected, the brush is turned on and the suction is turned on. It cleans. If obstacle is detected, it turns right and continues moving. And if the waste tank is full, it alerts the operator. Throughout the entire process, the patrol rover keeps monitoring the boat to make sure everything is safe.
In conclusion, this project was a lot of fun. It did take a lot of research, and I do believe that in a real world application, our robots would be beneficial, not only just for the monitoring, but as I said earlier, primarily for the safety of the zookeepers, as they are all durable and they're all able to be either remote controlled or they're completely autonomous. So that would lessen the risk for injuries and even potential lawsuits against the zoos.